Hi, it's Gadget UK here again, back for part 3 of the Atari Falcon restore, I guess. We did do some repair stuff in the previous 2 videos, little bits. But yeah, this video is finishing off, adding some bits that are missing, sorting out issues with video, and having a look all around the board as well. We'll look at all the different chips and things. So I fitted a battery on the real-time clock chip. So despite having done the DMA fix I did earlier by adding a termination resistor on the connection that goes to the Sdma, I thought it would be a good idea to fit something like this anyway to tidy up the clocks in general. I'll show you the main clock that we're talking about here. I'll just test on continuity. I think it comes into this resistor out of this side, and then if we measure from this side we're going to find a join. Got dead short there, 0, completely 0, 0 there. And let's try that one. Is it that side? Yeah, it's not that side, there's a bit of resistance there. 0 there. So as I say, the clock comes in through this resistor, connects to there, and to there. And each one of these resistors feeds off to various things. I think one goes maybe to the CPU, I'm not sure. Another one goes to the FPU, I'm fairly confident on that. And then the other one goes off all the way to the, I think maybe this one, all the way off to the Sdma, which is in this area up here, actually, the Sdma. So it's got a long travel, that signal. And the only thing isolating those 3 signals from each other is the resistor. In theory, if on the distance all the way up to the Sdma here, if it picks up some parasitic capacitance or something nearby influences the signal, i.e. because of the length of the trace, you get a bit of a noise or something there, or the chip itself causes some sort of little spike or something on that line, it can backfeed all the way to the point the resistor goes and interfere with the clock going elsewhere. Does that make sense? I think ultimately that is the, in layman's terms, that's the cause of the problem with the clocks on these. And as I mentioned earlier on, there are numerous ways you can tackle this. I will post a link down below to a website that outlines, I think, 8 or 9 different methods of using buffer chips here, like this. It's a little buffer, feeding the clock in, and then the outputs, splitting it into individual inputs on the gates and feeding the outputs of those to feed the individual places these go. So if some noise did backfeed, it's an output on here. It can't affect the input. Does that make sense? And I think the other thing is probably the other gates, the inputs are probably all tied low to stop the other gates from oscillating. But that's it, and it's a really nice clean design, this, from Ajax. I really like that. I think the idea is you put it like that and solder a little bit of solder there to bridge that, and a bit there. So I'm going to end up using a bit of wire here because it's bigger than the profile of the chip there. In theory you could fit it on the underside, but then you need the wires, you need little wires to come off from these points here. There's one for each of the 4 resistor points, one for the source coming in, I think that's that bottom one there, and then one for each of these. So I'll need to remove these 33 ohm resistors here and get these resistors off. I'm going to try and avoid damaging my little fix trace thing that I did there. I'll just heat it, there we go. It's come off on the tip of the my little pointer tool there, that's one. So this is the one that was missing, I think, because it's a bit bigger. I fitted a 1206 and I think it's a size or so smaller than that. I could do with being left-handed really to make this easier. There we go, it's come off now. And then the final one, now this one has never been off here, which is weird. Why would someone remove like 2 of them and leave one of them on it? Unless they didn't do the initial mod that had been done to this in the past correctly. That's a possibility. I'm hoping I don't lose any pads here. There we go, final one. Trying to avoid that wire added to the left of it. There we go. So that's all the solder removed, just the wires now. So what I'm going to do is I've got a tiny bit of sticky back in there that's just going to hold it off the board, and if I just try and get this into where I feel it's best positioned, and then just kind of plonk it down really. And there we go, so it's secured here and it's secured here, and it's sturdy, because obviously it's got a sponge pad holding it there, and obviously these 2 points holding it in position as well. I pulled the covering off these because they're such short wires. So the final thing to do is join this point here to the resistor that's already on here there, and then each of the points that join to this we're ignoring them, and it's the other side that need to go to the respective places here. So I've got the final one here. Let's just lift this wire up here. Yeah, I've got flux over there just from touching the board and then touching the top of that chip. I can clean up in a minute. This area is looking incredibly fluxy. So I'm finding the tip of that wire with the solder, just so that it makes it a little bit easier to try and melt back the end, but there we go, we've done it. I've already put solder on the pad below, so I can now just literally push that wire down, and I'm going to try and hold it into position if I can. Normally I'd be using magnification, I can't see what I'm doing. Anyway, that looks okay, I think. So all I need to do is clean the cotton buds, clean the tops of these chips and things, because there's the odd bit of flux, toothbrush around a little bit, and then we'll go test it. But before we do that, I'll test connectivity, I'll show you that. So I've got the ground on the outer edge of the board here. Let's just check that is ground. Yeah, that should be ground. That's correct. That shouldn't be, but it'll be. Yeah, that's a higher resistance there, so that's the VCC. The next thing we need to do is just check our connections here. So the clock comes in on here. This is 0 ohm link, so it doesn't really matter which side of this you solder, but I soldered on the pad up here where it went to, where we removed a component. So let's just check that. Yeah, it goes there. It shouldn't go to that one, it doesn't, and it should come here. That's correct. And then we do the first of the SMD resistors here. That should go to that pad. Just make sure it's not joined there. That's correct. And it's the same with this one. It goes over here, not to the pad down there. That's correct. And the same with the third one, the top pad, and not the bottom pad. One thing you want to be careful of, and I just need to just adjust that a little bit actually, is just lift it up a little bit. If you're not careful, you'll pull the pad off. But lift it up so that it's nowhere near this pad. You know, these pads on this side. This one here just needs raising a little bit. It's because I've been brushing it. There we go. It's just lifted away. Otherwise you could get some inductive coupling or something as the trace is flat across that other connection there, and you might not reap the rewards of doing the mod. So in theory that should be good to go now. So let me just reassemble it and we'll try it. So if you're doing this yourself, you might want to test with the 030 on board first. You know, just jump at that pin that I showed in part 1, I think it was, and power it with its original power supply, and just make sure it's working normally that way. But I'm going to go for broke here. Switch it on, and we've got no video. That's not good. So straight away there is a problem. So I'm not really sure which way to go. Everything looks okay here. I think I'm going to revert it and just stick the 3 resistors back on actually, because this was working perfectly in either mode, so you could argue that there's no point in putting this on here, but I wanted to give it a try anyway. So it's all working again after reinstalling those resistors and removing that board. You can see I ordered some more memory for this. One of the things I noticed, and I'll just stick an overlay while I'm talking about this, the CAS latency on the 256 meg DIM that I was using seems to be unsupported, which is interesting. Now I'd never noticed that because it was off the screen. As soon as I changed the screen resolution to a larger resolution, you could actually see the message. Anyway, so we'll fit this. It's 3.3 volt this, 512 meg, and is it CL3? Yeah, I think it is. It's like hopefully the right latency. So we'll have a go at fitting this next. So I removed the old one by just levering these, you know, pulling these levers apart. Now this slot is rated 20 insertions or removals, so be very careful. So limit the number of times you insert and remove these, because is it going to break? Yeah, I think that's in. Yeah, you're only going to get away with it so many times. And I think that's working. It's flickering a bit because it's in interlace mode. But now we can see more of the screen. We can actually see the messages and the timing here, you know, the speed on that RAM. 68.3 meg per second. So I'm going to make my own Scart cable, I think. It could have some interesting issues trying to merge these syncs to get a composite sync. Or I could maybe adjust the little adapter and add a switch to pass the composite to the VGA connector, assuming there's a pin that I can actually pass that via. But I've got BNC2 phonos here on components, you know, so you've got red, green, blue, horizontal, vertical audio. I'm not sure if I showed this. This is a Scart to VGA cable, apparently. And if we have a look inside here, you will see that is not RGB. I think you've got like the video in which is probably expecting composite, and the ground, and then I think audio channel, or maybe even 2 audio channels. So I don't know, maybe this was originally designed for one of these laptops where it passes I don't know, audio and video out, a composite signal via that type of connector, but I'm darn sure that's, well, I know that's not VGA, not at all. So what I decided to do was order a cheap extension cable, which I've got here. This was a male to female, and a minute ago I just chopped that off and I've stripped it back here, as you can see. The nice thing with this, can you see this? I thought this was going to be a nightmare to wire, but actually it's not. And not only has it got an outer braid here, you know, a shield around the whole thing, which means your signals are nicely shielded from noise, but look at this, we've got 3 here that have got a separate shield around them, and I don't know if you can tell, we've got red, green I think, and blue. So in terms of the RGB stuff, that's dead easy. That's the first 3 dealt with really easily there, because I've not had to hunt for them, you know, and do connectivity testing to the other end here, because obviously these are moulded, you can't open it and see where it's wired to. So all I need to do then is work out where the ground is and what these remaining connections are going to. We're going to have horizontal and vertical, but we seem to have 2 others, I think, well, 1 other at least. Yeah, we've got horizontal, vertical in the ground, and then something else. I'm not sure what that something else is. Now it does mean I'm having to cut off this ferrite ring thing here, but I've got some more of these that clip on. The reason I need to take this off is we can't get the grommet far enough back. It wants to be about back here somewhere. So yeah, anyway, it's not a big deal. As I say, I'm just going to cut this off, and I've got some brand new ones that clip on. So we are all done. It's taken me hours to do this, actually. It's surprising how long it's took to do this cable. So I've got an audio fly-off lead. I still need to get rid of that bit of grommet, you know, the plastic thing that was on there. It's not the end of the world. I've got a brand new, really nice, high-quality 3.5mm stereo audio connector there. That's belonged to the late Alison Shalley, so thank you very much for that, Colin and Nathan. And I'm sure Alison would have really appreciated the Atari Falcon. It's a lovely machine. I'm not sure if she had one in a collection. Colin's gone off looking in his loft just in case, and she's still got so much stuff up there in his loft. Anyway, so the way I got this working, obviously that audio connector is connected to the 3 things you can see down there. I've got red is the left, black is the ground, white is the right channel. I'll just pull this out a sec, and if I flip this around, yeah, you can better see those 3 connections there. Soldering, yeah, not great. Plastic a little bit melted. It's always fiddly working with these. So then I did exactly the same thing I did on that ST cable, because the switching pin here, pin 16 I think it is, we haven't got 5 volts to drop to around 3 volts. There is 12, but you've got to remember that what I'm doing here is plugging this into the VGA adapter, and I've modded that VGA adapter, put a switch on the bottom. I'll show you in a sec. What I decided to do was switch the V-Sync. So instead of V-Sync coming across this wire here on one of the wires from this connector, the composite sync, C-Sync, comes across. And that's just going into where the composite pin would normally go on here, you know, to provide a sync for your video signal. Your red, green and blue, you can see, are just down there. There's a gap in between each for grounds. I haven't joined them up, but they're joined up on the TV anyway, so sometimes you need to join them up, other times you don't. So for the switching signal, the H-Sync is unused, but it's coming across on one of the wires. So I did a similar thing that we did on that ST. On that video we used it was fixing that cable, an RGB cable there, we used the V-Sync. And what we did is the V-Sync came out of the cable here. We had a diode, a 1N4148. The anode is on the wire, the cathode goes to the blank-in switching pin. So that's going to mean that you can't backfeed down, in this case here, the H-Sync signal, because that's what we're using the H-Sync for that. And then I've got a 47 microfarad cap on the, across there, the positive of the cap on pin 16, the negative of the cap on the common ground over here. So as those H-Sync pulses come across, they go through the diode. It's TTL level, I think, the sync and the sync signals. Could be wrong, but it's it's certainly high enough. Probably around 3 or 4 volts-ish, I would think, in order to charge that cap up, keep the cap charged in between the pulses. which switches my TV into RGB mode, and it works. I've tested it. I'll show you that. I just want to use the hot air here just to heat shrink the few bits of heat shrink you can see there, and then we are done. So yeah, there's lots of ways I could have simplified this. I could have literally just got a connector suitable for the Falcon connector on the back there and wired a connector directly rather than doing it to the VGA connector, and that would have meant I don't need a diode and a cap. I wouldn't have needed to bodge the, use the H sync signal in the way I have, and I could have just fed 12 volts straight from the Falcon connector there, because it does provide 12 volts. But what I was trying to do is have something that's easily switchable and use the video board to do it. That little adapter board there, it just saves me trying to get a connector. Anyway, you can see that's shrunk quite nicely now. It'll just help protect things inside there. There we go, all done. There's the switch. I need to shrink the bits of heat shrink there, but all I did, if I just turn this over, the V-Sync signal normally comes up here. I cut it on the PCB. That way there is composite sync, or composite actually, I think it is composite video, because I noticed that when I didn't have the TV switching into RGB, it was displaying composite. So that's the composite pin there, and the one up here is the normal V-Sync. So those, either side of those are going to either side of the switch there, and then the common, the middle, is coming out to where it goes on here to feed either V-Sync or composite. Now an interesting point here, if I switch this on, you will see it works. The first screen there is nice and stable, and then you get some shimmering. I've shown this before, or you've seen this before, my TV before. This TV just does not like interlaced signals, but the interlaced stuff it shimmers with. I'm not sure why, but what is interesting about that, the reason I say that's interesting, is if I switch to the component cable, it's quite happy with interlaced mode. So it's something to do with the Scart input and how it handles the input there versus the component. But as you can see, that is crystal clear, absolutely crystal clear. And the good thing is that VGA cable I've used for this, it's, as I showed earlier, it's fully shielded, so yeah, it's come out really nice, really crystal clear display. And I think it's 8 ohms. I think is very similar in specs to the original one that would have been in this Falcon, but the one in the Falcon was a giant one on the underneath of the lid of the shielding, which I haven't got. So what I'm going to do is, as you can see, I've got a cable here, previously saved from something else in the past where I've cut it off. I'm just going to solder the contacts on here. Need to make sure I get those the right way around. I'm not even sure there's a designation on those actually. That could be interesting. But anyway, we'll solder those on there, and then I'm going to stick it down with some Velcro. I'll just cut a little piece of the male and female off here, and I can Velcro it somewhere, perhaps on the side of the Gotek or on the somewhere around the compact flash thing. I'm not sure. Oh, there's 2 speakers here actually. Look, they're stuck together with magnetism. Yeah, there we go. So our connection is just down here. Now it's never going to be like what they call a minty, yeah, to quote an overbook, a minty Falcon, or the chap that sent me this, because he's classes his Falcon, the one he's kept, as a minty Falcon. And what I mean by that is it's got all original hardware. It's probably got the original floppy drive. It's got the original shielding. It will have the original speaker. But this is custom. There's nothing normal about this whatsoever, really. You couldn't even fit the shielding back in here with the CT60E over here. So we need to do something, and I like to have a speaker, even if it's really tinny and awful. So you can see we're going to have no problems mounting that somewhere like on here, for example, or on the Gotek. I'm going to mount it on here, actually, I think. We need to watch out for those solder points there, obviously. Mind you, they're away from an area where it could be conductive, but I think I'm just going to mount it there on that second CF slot, actually. And that should do it. So I am curious, is that going to work? Let's see what happens. That beeping was the drive, not this, so I'm not really sure where that is engaged. Like if I press space here, oh, you can hear it. It works. Sweet. That's overloaded, that. Yeah, so playing some of that Beams demo, you can hear it's a bit tinny, that. I might try some of these other speakers I have here. that have been reclaimed from other devices. You can see that one there's 8 ohm 2 watts. I might go with that actually. It's got a nice big beefier fitting to it, hasn't it? The crazy thing with this one, right, the connector just plugs in. You can hear it's working, that's way better. And these mounts here, look where they go. We've got a screw here. That fits there perfectly. And that one fits there perfectly. That fits perfect. I can screw that on. So provided that fits underneath the case there, which I think it should do, that might be just the job. If you're interested, that came out of an old monitor. Yeah, so the volume's down again. Let me just load that Beams demo. Let's just see how much better that speaker is. I suspect it'll be better. Do you know why? Because it's got a proper diaphragm here. It's not that little fiddly little thing, you know, that's just not going to do anything really. It's so low power, that one from a DS. So the other one I have here is 16 ohm 2 watt. Oh my god, that sounds terrible. So I'm not happy with it, to be honest. I'm going to buy a special speaker that is designed to replace the original one. So I ordered another speaker, and I think this is 5 watt. It's 8 ohm. Yeah, it is 8 ohm 5 watt. You can buy these speakers pretty cheap on eBay. When I say pretty cheap, like, I don't know, 12 to 15 pounds. I think I paid a little bit more for this, and it had this 3D mount, but this mount is designed for the CT60 power supply, which I don't have. So yeah, is it going to fit in here? I honestly don't know. What I'm thinking is I could probably slide that underneath the IDE thing, because this, you know, the cable's under there, it's quite taut, and there's just enough room for the width of this between the drive bay and the floppy disk drive. So I think that's how I'm going to mount it. I love going inside this machine. It's just so glossy and sexy, you know, all these different contrasting bits of technology and stuff in here. It's just gorgeous. Anyway, sorry about that little diversion there. What I was going to do is just disconnect the power supply. Can you see what I did here? If I just pull that off. In the second part, I showed you it was an adapter plugged in here. So I just got some heat shrink and slid it over there and shrunk it. So it's like super tight at the top there, and it's super tight all the way around, so you can't pull that adapter off. Well, you could do if you really, really forced it, but that's not going to slip off, and I'm not going to mix the polarity up. Yeah, so it's totally unorthodox, but what I'm thinking is if we just lift this up and actually fit it like that there. You can see I've tucked the floppy drive wire like this here, but I think it will be okay, and it's not going to go anywhere once it's actually tightened up. There should be enough room. There is enough clearance, you know, the cables don't press too much there. So yeah, I think I can pull it off. But anyway, if we just move this out of the way, the connector, so you can see we've got that nice brown coloured connector there, and it just corresponds with, can you see it just there where my finger is? Brown connector there. It's amazing they managed to get the same colour connector there. You'd think it'd be something more modern, like white or something. So I'm just going to just twist this wire a little bit so that it sits on the underside like that. You know, it's kind of curled up. And if we just plug that on, and then, as I say, I am going to wedge it under there like that, I think. There we go, all secured. That isn't going anywhere, is it? Just testing it. Yep, you can hear it's working. It sounds a little bit tinny, but I guarantee that is going to be way better than any of those other speakers I've tested. Certainly because it's 5 watts, but not only that, it's the type of cone and stuff. This is, you know, a much more expensive speaker. So just tested with the speaker disabled, and that's working. Now the interesting thing is, I think there might be a bug in the operating system here, because while you can disable it from the control panel, it doesn't stay disabled. So I've managed to find a way around that. I found a little executable you can run that just disables it. So I've just got that in the root of the C and the D drive. It just means I can just run that when I need to disable the speaker. You can hear it's working. Sounds very tinny, but I tell you what, it is probably way better than the original one, and it's certainly leaps and bounds above the other speakers I was testing. You can hear it, and if I run that speaker off, now it's not doing it. So that's the way I'm just disabling the speaker. You could argue there's no point in putting one of these in here, but it would have originally had a speaker, so at least I like it to have its original functionality. So with that speaker at about half volume, you can hear that's a lot better. It no longer sounds like a load of ants line dancing on tinfoil. I've put a screw in there and a screw in there because we only had the two at the front. And on the motherboard here, I've put a screw there, a screw there, and a screw there. I may try and fit a screw there as well. I mean, technically there's one or two others under the edges. So I'll have a quick wander around the board. I'll point out what things are and talk a little bit about some of the chips. The CPU is down here. After I've done this, by the way, I'm going to clean up. Yeah, so I was right with that. That is the CPU. It's a bit of a weird place for it to be, but I gathered just from the number of pins on that, and the part number was a clue as well. Although it doesn't give much of a clue there. That's an 030. I think there's a 30 in the code there. Yeah, there is. SC414230 FE, I think it says 16. So that's rated at 16 megahertz, and actually it runs at 16 megahertz. So even though this is a 32-bit processor, it only uses a 16-bit data bus as the backbone for this system. So, you know, technically you could argue it's a 32-bit system, but it's for compatibility reasons I think they went that way and used a 16-bit data bus to communicate with the various things in the system here. And it's got a 24-bit address bus as well, just like you get in the earlier STs. So the large quad flat pack here is Combel. This is kind of like the backbone of the system, in my opinion. It's a gate, you know, a very large gate array, if you like. Looking at the pinout from the schematics, I can see references to IDE connections there. There are some Joy connections. I think it's primarily like driving all the chip selects and things for the various chips on the board. You know, it's going to have all the address decoding in there and various other things for moving data around and for arbitration, effectively. RAS and CAS, I see some RAS and CAS signals coming out of there, and sound chip select signals as well. So, as I say, I think that's kind of like the glue that makes the Falcon the Falcon. So the gals down here are just a bit of glue logic, I think. You know, they're probably just doing some decoding on various signals that, I don't know, that couldn't be done inside here. I could be wrong, but there's nothing particularly special about these, I don't think. And you know, obviously there's not many pins on them, so there's not going to be much logic in there. The real-time clock chip we've already covered. Originally that would have had a Dallas DS something or other on there. We will, in a separate video, decap that chip actually and just see if we can fit a battery, you know, a button cell holder on the top. And obviously, as I mentioned earlier, this holds some settings, you know, it's got some RAM in there as well, so it holds the configuration of the system between power cycles. So 7.4 series stuff here. I'm guessing that these chips here may be doing some buffering for the ports here, you know, actually analog ports, aren't they? These solder blobs here are used to configure wait states related to the ROM timing, as far as I understand. I don't know why, but there were some issues with the types and speeds of the ROM chips that were available to Atari at the time, so they used these to slow or slightly speed up access to the ROM via wait states. And you can see the PLCC ROM chip here. In this particular one, I've got TOS 4.04. I think originally these shipped with the very early ones with Rev 4. We have the FPU socket up here, so it's like a standard 68882. I think you could probably fit a 881, but there's no point in doing that. I'm not even sure if the PLCC version was available of that earlier one. The 68882 is you know, enhanced over the original one there. This is rated at 40 megahertz, the one that's fitted on here, but it's probably running at the same speed as the CPU. I'd imagine that's probably running at 16 megahertz. So we've got the MFP back here. In this case it's a PLCC version. I think on the ST and STE and stuff you'd probably have a DIP version of that chip. It normally sits near the CAAs. There's one of them here actually. This CAA is for the MIDI ports here, you know, so this is like a serial. It's similar to the CAA you get in an Amiga, but obviously it's got a lower pin count here, and yeah, it's targeting specifically the MIDI serial communication. And this chip kind of supports the two CAAs. There's one on the other side I'll show you in a second. But the MFP also provides, you know, interrupt control, serial and timers and stuff. And again, we've got some, you know, sort of off-the-shelf Jelly Bean logic here. And you can see the opto-coupler here for MIDI, just like you get on an ST-FM or an STE or any of the other ST series. This chip at the back here, I couldn't find much on that. I found it on the schematics, and I think it's related to the LAN stuff over here. I could be wrong. It just kind of looks that way to me. And we've got like an AM26 something there. I think that's like a line driver or something similar. So that might be related to something around here connectivity wise as well. This little dinky quad flat pack here that's marked Yamaha, it's the 2149, I think. It's got a slightly different part number on it. It may be that they just gave it a different part number as they put it into a smaller package there. It might even be slightly enhanced over the original one, I don't know. But that's what gives you backwards compatibility with ST sound. And before I forget, there's the other 6850. I think it's marked actually EF68B50P. So I'm not sure if these are interchangeable with the ones on an ST. They might be. Bear in mind the original ST would have had lots of things like this clocked at 8 MHz or 4 MHz or something like that. So I'm not sure if it's exactly the same on this or whether this is an uprated part to handle, you know, most of the backbone of the system running at 16 MHz. That might not be how fast these are communicated at. It might be on a different clock domain or something. We've got another, what looks like a GAL or something there. I'm not sure what that is. I've not looked the part number up for that. And while we're in this area of the board, we'll cover some of the other things here. So I noticed 3 RAM chips here. I think these are 6264s. I'm not quite sure how large those are. Might be 32K or something like that, actually. So you've got some RAM here that is directly accessible by the codec and the DSP. So this is the DSP here, digital signal processor. This runs at 32 MHz, whereas the processor runs at 16. So this is capable of 16 million instructions per second. The CPU is rated about 5.76 MIPS. But the DSP is kind of geared towards, well, as it sounds, digital signal processor, signal processing. With it being connected to the codec, I would imagine it would be able to process audio signals coming in. But it's also connected up to the graphics side of things, this. You can get it to do fractals and things, you can get it to decode JPEGs. It's used in conjunction with the CPU to play MP3 files. This will play MP3 files even with the stock 030, and it's crystal clear. It sounds fantastic. And you could also, you know, get that to do 3D calculations and transformations and things like that. But this is one of the key points that makes the Falcon as powerful as it is. Had it not had a DSP, it would be a much weaker machine. This really adds a load of oomph into the system. And as I say, related to the RAM, I think this codec is connected to there. So yeah, this is a codec. It connects to the audio input ports up the top there, as far as I can gather. So any audio coming in from the, you know, the line in, it's going to be sort of captured. I'm not sure exactly how what it does, whether it just captures it, sticks it in here, and then this can process from there. I'm honestly not sure, but yeah, this is responsible for, let's say, the input and the input of the sound there. I'm not sure about output. I think it's literally just stuff coming in, gets encoded some way and stuck into RAM, and then the DSP can process it. So the other huge, large quad flat pack on here is this Lsi Logic Chip here. This is the Vidal. So this is kind of the graphics chip behind the Falcon. This provides compatibility, some of the modes in there. You've got compatibility with the original video modes of the ST and ST-FM, but it also provides, you know, the additional functionality that you get within the Falcon to get higher resolutions and stuff. From what I understand, it's very configurable, this. You can feed an extra clock in through the port on the back there, through the video connector, and kind of overclock this slightly to get higher resolutions. You know, it's limited on the crystal speed that feeds this, dictates the resolutions you can go to. Like on the other ST machines, I think the video RAM shared with the main work RAM, you know, program code RAM. So you've got a bit of a bottleneck there. So I think if you go too high a resolution, your performance obviously degrades the higher resolution you go. But with the enhanced functionality this provides over an ST, you can get 16-bit true colour, 65536 distinct colours on screen at once. But I think if you did that, the performance is going to drop a little bit. 256 colours is probably a more usable colour depth to go to. You're probably going to get very good performance on that. I set the desktop on this to 256 colours actually. And behind Viddle, the graphics chip, we've also got an MC1377P, so that's exactly the same chip you get on an Atari ST FM, or I think on the STE as well, and you get them on Amiga modulators. It's a standard PAL NTSC encoder, so that's going to be taking the video signal and converting it into composite for the modulator back here, and I think you get composite signal out on the back somewhere on the video ports back here as well. And the thing that feeds that encoder there, the 1377p, is the video DAC here. So this ultimately is going to be fed connections from Videl, probably. And obviously it's converting digital to analog signals, and the analog signals are encoded via that chip there. But the analog signals also that come out of here are going to go straight to the port on the back there, the video port. So you can have red, green, blue, H and V. The H and V may not come from there directly, they might come from somewhere else on the board, but yeah, anyway, that is the video DAC. And I think those do fail because Exos, I'll post a link down below, his web store, he sells those as a readily available spare. So the IDE, as I say, I think is connected to Combel primarily. There may be other things around here that support it, but I think yes, the control signals are provided by Combel. But ultimately it's a PIO mode, programmed I/O. What that means is the CPU is doing most of the legwork there with IDE. So just above that there, we've got the Ajax chip. So it's got an Atari part number on it, but this is your WD1772 effectively, that runs at 16 megahertz versus the original 8 megahertz that you would have got on a standard 1772 on an ST-FM. And the double clock speed there versus the original 1772 means that this works with 1.44 meg high density floppies. And just above that there, we've got this Logic chip here. Can't quite read the part number, but I know that that's the Scuzzy Controller. Actually, it's right next to the Scuzzy 2 port here. I'm not sure if it's like a Scuzzy 2 wide, or I'm honestly not familiar. It just looks like a Scuzzy 2 port to me. But yeah, that's the Scuzzy chip there, and I think this has got DMA capability, so you're going to get better throughput and transfer speeds and things, in general, if you use Scuzzy versus the programmed I/O. But you may find, like me, that the IDE stuff is significantly faster when you're using an 060. That said, there might still be a bottleneck on the IDE versus the Scuzzy. The Scuzzy's got DMA, so what that means is it can transfer data without any assistance straight into RAM. And there's the Sdma controller. So as far as I can understand, this is the main DMA controller, but it supports the sound and Scuzzy DMA stuff too. And you can see where we did that mod in an earlier part of there to pull a ground from here and just ground the clock signal. Well, not ground it, but terminate it with a resistor there. And that solved the clock instability issues for me on this board. We've got another one of those what look like a line driver or receiver or something there. It's an AM26 something 31. I think the other one was a 30 over the other side. And I guess it's worth pointing out something else to do with the audio around here. You've got these little small op amps here. I think that's maybe an op amp. I can't quite see the part number from here. But anyway, these two chips here are definitely op amps, and we've got some caps and things around here. So I'm guessing, obviously it's right next to the codec as well, and the connectors on the back here. So yeah, input and output audio amps there. Incidentally, I think there are lots of revisions to these boards. Now, I was looking up I'll show you the version in a sec. I was looking up this board and trying to work out what modifications may or may not need doing to it. And I think I'm in a good position with this one. It's Rev C, and there were some modifications, but they seem to be aimed at trying to deal with the clock problems. There was one other set of modifications that I'm aware of, which is to do with tweaking the audio stuff here. So it involves like removing some resistors and caps and things and fitting some of the things in other places To me personally, I don't think I need to do that because it sounds perfect. I've tested the audio input and I used the audio output and it's crystal clear. There's no noise or volume issues or anything, so I'm quite happy with it. I don't think I would go as far as trying to fit the mods that Atari recommended in later revision boards. Main fan here for getting some air circulation going throughout the system, and the two connectors here that are required when you fit a memory expansion. And then at the back here you've got the main two expansion connections. Well, you know, this is where the CPU expansion board fits over. And spread around the board there's just some jelly bean stuff, you know, 7.4 series in various places, doing various things, mostly like buffering and stuff like that. So before I clean it up, I'm just going to get a screw in there as well. I'm not doing these ones very tight because you can see it overlaps like half and half. If you tighten it too much, it'll just pull sideways and bend the fitting and stuff. But because this is lacking the shielding, you know, it's not got any security on this side of the board here, and obviously the better this ground, I'm sure it'll be the same on the underside of the PCB, is joined to the shield on the underside, the better grounding you're going to have in general. But you wouldn't want to over tighten a screw like that. But you can, however, tighten up a screw like that because it's not overhanging at the side like those other ones are. So I'm not going to show you all of this. I'm just going to go over this with cotton buds wherever required. There's a sticky mark or something there, so I'm not sure what caused that. It's just a case of inspecting very closely and just cleaning any marks off that I've got on there. The other thing I will do is get some heat sinks. You may think I'm crazy, and maybe these chips don't get hot, I don't know, but I'm going to get heat sinks on the main chips here because you can't get replacement spares. Well, correction, you can buy them from Best Electronics, and I think Brad is quite happy to sell you a spare Vidal for maybe $1,000. He's got 7,000 of these, and he won't part with them. He's selling them at crazy prices. So it's a real shame because I think there are people out there wanting to make, or already have started to make, a replacement motherboard. We just need the custom chips. Well, Brad's got plenty of them, but he doesn't seem to want to sell them at anything like a reasonable price. You know, if these were sold at $50 each or something, or even $100 each because he wants a premium price, you could even argue a crazy price of $200 each. At least then new Falcons would be able to be manufactured. Anyway, that's just my personal opinion. So I'm all cleaned up. I'm going to stick my heat sinks on now. So you can see I've got some small copper heat sinks here. I've got some different ones for the larger chips. Just remove the heat back in here. It's got 3M thermal adhesive, and we'll get one on top of the DSP here. As I say, I am not sure how hot these chips get, if at all, but any kind of additional thermal dissipation you can provide may just extend its life. And you can see the traces kind of run up here to the DSP just underneath the floppy drive there. Now I know because I've had a look at the specifications of this machine, the DSP has a 24-bit data bus, so that's why you've got three. It's like you've got 8 bits, 8 bits, 8 bits, adding up to 24 bits. So we've got a heatsink on the Sdma, the DSP, the codec, the Scuzzy chip. Again, like I say, lots of these things probably won't get hot. I would imagine that may get hot. Vidal, the video DAC, although again I don't think that's going to get hot. And we got one on COM and one on the CPU. Of the chips on here, I think you pretty much get off-the-shelf replacements. I mean, like the stuff back here, you know, the FPU, it's off the shelf, you can replace that very easily. Some of the other chips around here, I would imagine, aren't going to get very hot anyway. Looking at the MFP down here, it looks like it's got a clock here for that, a crystal here, and it's a very low frequency actually, it's like 2 point something megahertz. And I guess you can't really do much about these unless you were to put a heatsink across them. I guess in theory you could put a heatsink like that there. Shall I do that? You can replace these, I've got the JetX for those. Now from my testing they don't get that hot, but if you're overclocking, as I will be doing periodically on this, you never know. It's not going to do any harm. We've got plenty of space there, look. So I'm going to skirt over a lot of this. I'll just show you the end result. I'm having a go at fitting the Exos one the exhaust board here. So I'm just going to, if I can get the iron at the right angle, just try and heat that point there. Obviously I've got to be careful I don't break the trace here. There we go, just move it out of the way. There we go, it's off the trace. You can see that? It's free now. And then we'll just grab it with the tweezers. It really should have been an SMD part anyway, so even if I wasn't doing the clock mod board fitment here, I would be swapping that resistor out with something more suitable. Yeah, that's it. So I'm going to clean up around here with the cotton bud and some IPA, and we'll have a go at fitting this PCB. Now, the one that Eiji Arana sent me, he did say it was just one he had knocking around that he thinks might be okay. So I think it is one of those where it just needs a new chip on it. So I think the Eiji Arana one would work just the same. So you can see we've got a point down here for the ground, I think, a point there for the VCC. So I'm going to need to solder some wires on and mount that first, you know, with its power and ground, and then it's just a case of doing the same thing, remove all 3 of these and have 4 wires. So the reason to do this, I think Exos was telling me, it pulls the signal too low when you have that resistor there. It works, solves the problem, gets rid of the reflection issue, I think, but ultimately it's better to have a little PCB in there like this, buffering the individual clocks going to the relevant places. Right, that is it, we are all done. Now this is a simple mod. It's super stressful doing this, if I'm honest, because you can't get spares for these. Well, you can get them from Best Electronics, as I mentioned earlier. Good luck trying to get a spare, you know, seriously. If you can convince Brad to go and get you a spare Viddle or a combo or something, yeah, you're super lucky. So this is the thing, you know, if these were really abundant and there were loads of spare boards knocking about, I wouldn't be half as worried. But just based on the fact they are super rare and super blooming expensive, you can imagine why I've been a little bit apprehensive about doing this mod. You know, even just the risk here of removing these pads and things, I just don't like the risk. Oh, I don't believe it. After all that, it doesn't work. This does work compared to the previous one, i.e. boot, but it's just frozen. See, it's not even looking at the compact flash card, it's just hung. Now this is the problem I had before I did that mod with the resistor. So super annoying, because as far as I can see there's nothing else I need to do to this. It is just flaky without that resistor. I could try fitting that resistor back on again, but it kind of defeats the object, doesn't it, really? I may as well just revert it. Let's try that beams demo. Now Quake, I've tried it a few times there, it just hangs. So that was the original problem. Now bear in mind, the point this froze was when oh, it's froze already. Froze already. So yeah, I'm sorry, Chris, you know, Exos. I don't know why. There must be something different about this revision of Falcon I've got here. I don't think there's a fault with it, because when that resistor's there, it runs fine. You can run it for hours and hours and hours, no issues at all, but this does not work. So I'm giving Exos the benefit of the doubt here. He's come back to me with a few things, so I thought, well, let's try it. I wish I'd not removed it again, because yeah, I'm having to redo and redo, and of course pads and things are going to go missing if I'm not careful. So we've got 100k resistor here now. That's what Exos suggested. There's a little bit of flux needs cleaning off there. So I removed all the solder from here, made sure there are no shorts to ground. This time I've used these pins, the pins that Exos provided, and mounted the chip on the underside like that first. So, and the way I did these is I have the black plastic piece at the top here, so there's a shorter piece here so that it won't hinder the chip going into the socket. Now we've completely soldered that on, I can literally just carefully trim off these extra long legs here, and hopefully it should be alright. I need to just make sure we have no shorts again. So, oh, see, that's what I didn't want to do. Drop that pin on here, I need to find that. So I just carefully tipped it upside down there whilst looking very carefully, and I saw the pin fall out, that little pin that I trimmed off. Let's just make sure it's lined up, it is, and just carefully push it in. There we go, so it's back in. Yeah, that's much more secure than it was before, but this side here is not going in very well. Can you see that? This is the problem with these stupid blooming pins and the solder. You know, the solder is just a little bit too far down here, so I'm going to need to adjust that. Right, here we are again, ready for testing. Let's just make sure we don't have a short between ground and VCC, and we don't. Let's check ground to ground. Hang on, that's good. VCC to VCC. It's not making a very good connection, though. Yeah, that's it. And then we need to check these. So the left one goes to the top of the right hand resistor, that's correct. The left one, next left one, top left of that there should go to the via there, it does. The middle one is the top of that one there, that's correct. The right hand one is the clock input from the bottom pad down here. Why is that not joining? And that's correct as well. Just make sure these aren't shorted. Yeah, those aren't shorted. Yeah, those aren't shorted. Yeah. So, the only thing I can think that may need trying now if this doesn't work still with the 100k resistor is to change this jumper here. You can see there's like 3 pads from the bottom 2 positions to the top 2 positions. He's added a delay on one of the clock signals here. I'm not sure what that's for. It's for compatibility with something, but I think from what I understand the way he's shipped these out, that's enabled as default. That might be causing me the issue, but it may have just needed that 100k resistor. So let's go and try. I seriously hope this works because I am cheesed off doing these clock mods on this. It's a mess, the Falcon in general, isn't it? It's no wonder things like this have had to be produced, but there are so many variations, it seems, between boards. It's really easy to find that a fix like this works on one board and not on another. So the good news is, first impressions are it's working. It loaded, there were no hangs or anything loading. Normally, if you've got a problem with that DMA clock line there, it will freeze load and quake for me on this machine consistently. So that's good news. So whilst that's just going around the demo, I'll just waffle a little bit about what I think is going on here, and it's interesting actually. The 100k termination resistor is what fixed this with this mod board here. So if you've not already gathered, you've got the 1 clock coming in, you've got 3 clock signals going out to various places. The Sdma is one of them, goes all the way over there, and that's the one that's causing me a problem. Now in part 1 or part 2 I think I fitted 33 ohm resistors there. That gave me a lot more stability, and then of course we needed that 47 ohm termination / pull down on the Sdma clock signal there. That obviously was working for me. Now what got me thinking about doing this and revisiting here is something Exos said. He's done quite a lot of work looking at all the different revisions here and all the different mods that you can get, because there are several of these. I'll post a link down below. Different clock mods that were done by Atari and by third parties, and in recent years by third parties, to try and resolve all these weird clock problems with the Falcon. So in my case just the Sdma, but from what I understand you can have problems with the other clocks as well. That was one of the reasons I think that trace had been cut around the FPU area, the one that goes to the FPU I think. I could be wrong, but yeah, there had been a trace cut there. So this is basically taking the clock input, splitting it 3 different ways. There are some passives on here, some resistors and capacitors, perhaps just to tweak some of the signals so they're optimal. But of course we do have that 100k resistor now on the Sdma clock line, and you may be thinking, is that doing the same thing? Is it? And it is and it isn't. It's acting as a weak pull down, that resistor over there on the Sdma, but also I think it's terminating a little bit as well, because I think the problem I had on the clock line that goes to the Sdma is some reflection. I think reflection was going on, and I think that 100k resistor is doing 2 things. It's a weak pull down and it's acting as a termination resistor, but it's obviously only 100k, so it's much safer than the 47 ohm resistor we had on there. And that's the thing, that's what I was trying to get to, the point I was trying to get to. That Exos pointed out that on one of his machines he measured the voltage over there and it was like 500 millivolts, which is dangerously low, and it's no wonder it wouldn't work on that machine he was trying it on, because that level is just way too low. You want, around 3.5 volts as a minimum really. Around 4 is ideal, and I think this is what this outputs. And the other thing is, this is direct from Exos's blog, what he noticed is that clock line that goes to the Sdma, I think he said it was like, it starts at -1 volt or something, and it's overshooting as high as 6 volts. And those are the issues that you get with that clock line, probably because of the length of the trace, impedance, capacitance that's built because of the length of it and how it runs and what traces it runs next to, etc. But the way I had that termination resistor, the 47 ohm, if you think about it, I had a 33 ohm, and that was a bit risky as well. I changed a 22 to a 33, and you get in a voltage divider. The clock comes in through the 33 ohm, yeah, and then at the other point of the side of the resistor, it goes to the Sdma chip, but then you've got the other resist between ground and the point that goes to the crystal input, if you like, the clock input to that chip, which means you've got a voltage divider. It is literally, and I think he described it as crowbarred that signal, and I can sort of see his thinking there. It's like, say you've got a potential divider, and you one resistor at the top, one resistor at the bottom, and depending on the size of the resistors, you can actually shift the voltage level. So where we had like 6 volts, when you do that crowbar thing with the 47 ohm resistor there, you're shifting it quite far down. And actually, I did the maths. I actually calculated 6 volts in the arrangement of resistors I had there, and it drops it to like 3.5 volts. So it's quite a bit, in terms of currents. I would imagine there is a risk that maybe the pin that feeds into the SDMA could take offence to some excess current there, or maybe it's origination, whether it originates so further into the board. But you've got that 33 ohm resistor in the way that limits current to that anyway. So I'm not really sure exactly where the risk would be. I would think at the SDMA end. So this is safer. If you follow the first 2 parts and you fitted a 47 ohm resistor to resolve your clock problems, with or without a CT60E, just have a revisit and consider fitting something like this. Yes, it's a little bit fiddly to fit, but as we seem to have proved, I think, all the time being waffling here, it's still running. It is pretty stable. So I'll do more testing on this. I'll report back in a few minutes. While I'm reassembling this, it's worth pointing out that this is actually from an ST or an STE, this keyboard frame, the actual plastic part. The keys are obviously from a Falcon, but this would have been like a dark grey rather than the cream colour here. So, that is something that's different about this. I mean, I could, in theory, take all the keycaps off and I could spray it the right colour, but it really isn't that big of a deal. But it's the sort of thing you may find when you pick up a second-hand Falcon, because you sometimes get damaged traces on the PCB, and rather than fix it, people seem to have just swapped over to another keyboard and just, swapped the keycaps over. So I thought it was a good idea to run the Dma Test program again. I didn't show you this. I showed you a similar kind of test. It was an audio-based one, actually, in the diagnostics card in the previous video. But this is something that Exos recommended to try. Now, I had run it before, and it ran okay with the 47 ohm termination resistor, but that green screen there shows that it's actually working. If you've got DMA problems, you'll get red lines and spikes and things, the red. It won't look green, you'll see red there. I think it does like a DMA transfer to the DSP or something, so any irregularities with that transfer will show up there, like saying red. The other one in the same folder, I think, is a fast Fourier transform thing, which just goes off the audio input. So I think, yeah, there we go. What we need to do here, so we've got some noise there already, which could indicate I have a problem, but it could also be related to the audio input. I mentioned, I think in a previous video, or even in this video, there were differences done between the boards by things from Exos Web Store. Yeah, there were differences on the audio input, so we got a little bit of noise there, haven't we? Bear in mind it's plugged in. If I unplug it, yeah, a little bit. So you could argue that from that side of things, maybe I need to do some mods to the audio circuit, but you know what, I'm quite happy with the way things are, so I'm not that fussed. And incidentally, in order to run that, it took me a while, it took me blooming ages, because it's 6 months since I played around with this, if I'm honest. I had to disable the auto folder. Now there is a way to do this. You can hold a key combination down on boot or something, I'm sure you can. But you can just rename it and put an extra character there, change it from auto to something else, and that will get rid of it. But yeah, I had to do that, get rid of NVDI, because that was stopping it from working, actually. Get an interesting combination of sound here when you've got the sound coming from the TV and the speaker. It's on full volume as well, so it does sound pretty loud. Just for information, I'm not sure I showed this in previous videos, I ran Genbench here. Now, floating point math, it's way faster than that, but actually it fails on this test. I'm using Genbench 6 here, so and you can see a bit of corruption at the top where the exception was raised there when it was testing. But nevertheless, I was able to continue and it tests everything else. So I'm not sure whether that's a clash with NVDI or something to do with the 06. So I'm running this from Alt-RAM, I think, at the moment. But if you look at the performance here compared to a stock ST, it's off the scale, isn't it? Average 1,310%. That is incredible. Well, my screwdriver is doing my head in. I've got one of these. I bought this many years ago when I was studying, actually. And it's just got magnets in it. You just stick your screwdriver through like this. This screwdriver, as I say, was seriously annoying me because it was just not magnetic in the least. If I stick a screw on that now, you can see it's very magnetic. I had to pull that off there then. So we're all done now. I'm going to get the lid back on and start using this. You could argue that I could clean the keys and stuff, you know, I could take these keys off with a keycap removal tool and have a good clean underneath them. I'll do that at some other point in time. You've seen me restore one of these keyboards, you know, an ST keyboard, because that's what it is. It's just got different coloured keys here in a previous video. I'll stick a link up there. So I found a replacement screw for there on the keyboard. So as I said earlier on, you may think I'm crazy leaving that bag there taped into the drive with the original mounts and things, but it just means someone can easily revert it. So the longer screws go at the back here because they go through the long support pillars that go right through the case. The head on that one, it's a little bit worn actually. Let's just try and tighten that. Yeah, that's it. So looking on the underside here, it says memory 4 meg. Hard disk 60 meg. So yeah, this would have originally shipped with a 60 meg hard drive. I'm guessing it would have been in that little metal caddy you saw where the compact flash interfaces are sat, and it must have been a 2.5 inch drive sat in that space there. I'm assuming a 2.5 inch drive would fit there. I think it probably would. And you can see the serial number here. There weren't very many of these manufactured. I think, I could be wrong, but I think in general there were at most 20,000 manufactured, and I think only 12,000 or so of those are the ones that actually shipped out various places and were sold commercially. There were around 8,000 or so that eventually got bought by another company after Atari sort of started to get into financial difficulties or folded, I'm not sure which, and they produced like a customized version. It's got a different label on the front, and it was aimed at the professional audio market, so there were some subtle differences. They did some mods inside, just little tweaks and things, probably stuff to do with the clock, and they probably applied those audio fixes that I haven't applied to this, but it had a different badge. I'll stick it up there. I can't remember the name of the company, and I think the company was based in Germany. I think incidentally, I think these were all manufactured in Germany originally. Let's do a quick clean on the underside. You can see got some marks and things on the underside here. So there's very little to do to the outside of this. There's the odd black mark like that there, just a bit of dirt, but it's in very clean condition. It has been sat around for a few weeks as I've worked on this throughout this series here, so there's the odd little bit of dirt just got onto it.
House Atreides.
Reporting. Acknowledged. Yes, sir. Moving out.
Enemy unit destroyed.
Yes, sir. Moving out. Reporting. Affirmative. Reporting. Affirmative.
Sort 'em out. let's look around.
Okay.
So, the legend of a labyrinth hidden under the ruins of Knossos is true. The legend of Atlantis isn't any more far-fetched. Maybe it's true, too.
I think the last stone disc and Atlantis are waiting for us somewhere beyond that door.
And there we have it. She's absolutely gorgeous. I have thoroughly enjoyed working on this machine. I cannot thank William enough. It is just unbelievable that, you know, the generosity of donating this to the channel. And it isn't just a Falcon, it's got a CT60E in there as well. It's just amazing, absolutely amazing. As I said in part one, if you ever need anything repairing, William, just send it to me and I will sort it out. No problems at all. Even cost of parts on things for repairs, I don't mind funding that, because it's gradual. It's the sort of thing that, you know, alright, you could argue that if William sends me repairs for the next 10 years, it could end up, you know, being the cost of something like this. But you know what? I couldn't have saved the amount of money to get one of these, and they're going up and up and up in value. At the moment, there's a few on eBay for around the £2,500 mark, which is ridiculous. Yeah, it's not just about the monetary value here. Obviously, the money value of this is just amazing. I would never sell it. It would be one of the last things to go in my collection if I have to sell things, I think. Yeah, I love it. Absolutely love it. Thank you very much, William. So hopefully you found the series here interesting. We'll probably come back to the Falcon at some point in future for something, I'm sure. It's definitely not going to be the last time we'll look at the Falcon. I might even do a live stream on it at some point and play some games and demos or something, just have a bit of a chat and a waffle. So anyway, I do hope you found the video interesting. Please leave some comments down below, like, share, subscribe. If you'd like to support the channel, please see the Patreon and Ko-fi links down below. I'll catch you in the next video.